Hi everyone, and welcome to this series of circuit practice problems. And here we will have a mesh analysis question. And in this question, basically, we will learn two things. The first one is how to deal with a dependent source. And the second thing now, what if the independent source is basically between two loops? It's not on the side of the loop. So how we can deal with this situation? So we need to find in this question, what is your V out of this circuit? We have here a current dependent voltage source. It's 4000 Ix, and Ix is the current in that direction. So again, this is using mesh analysis. So we start by assuming the loop current. So we'll have here I1, I2, and I3. So starting from loop number one, okay, so we have here a resistor and voltage sources. So basically we can apply KVL. So KVL to loop number one. So we'll have 4K 4000 mean Ix plus 10K I1 minus I2, we close the loop, is equal to 0. Now, as we know in mesh analysis, basically we need to have the number of equations equal to the number of loop currents. Now we have here, because of the dependent source, an Ix. So I don't want to propagate and continue with this question and having Ix as another unknown. So let's figure out what is this Ix. Ix is the current going in this direction, as you see here. And I2 basically is the current that going in the same branch, but in an opposite direction. So basically your Ix is equal to minus I2. So this is, if this is my equation number one, this is equation number two. I will substitute 2 in 1. So we will have minus 4K Ix plus 10K I1 minus 10K I2 equal to 0. Now let me add terms. So we will have here basically 10K I1 minus 14K I2 is equal to 0. I can divide by 2, so we will have here 5K I1 is basically equal to 7K I2, and this is my third equation. Okay, now I need to go for loop number two. Now, when you go to loop number two, you will see that the current source is in the way. So I don't know the voltage here. I cannot express the voltage as a current multiplication with resistors. So I don't want to introduce another unknown and increase the number of the equations. Also, if I go to loop number three, same thing. The 4 amp independent current source is in the way. So I cannot apply KVL to loop number two. I cannot apply KVL to loop number three. Now, first we can get an information from the 4 milliamp current source, which is basically the current that goes here in that branch is I3 minus I2. So I3 minus I2 is equal to basically 4 milliamp. And this is my equation number 4. Now we need one more equation, because this is one equation, number 3, number 4. So we need one more equation, and that equation is basically, I will take that what we call the super loop, which is a loop that is composed of 2 or more loops. Okay, so when we take the super loop, we bypass the current source. So the current source is not part of the loop. So we'll start here as, so KVL to the super loop. So we have 10K I2 plus 10K. So this is 10K I2, 10K I3 plus 10K I2 minus I1. And now I'm coming back to the point where I start, equal to 0. So let me collect term here. Before that, I can cancel the 10K, take it as a common factor. So I have minus I1 plus 2I2 plus I3 equal to 0. And this is my fifth equation. So now I have three equations, 3, 4, and 5, three unknowns, and we can solve for that. Now, one way, now what I want to find V out. Now, what is your V out? V out is nothing but 10K times I3. So if I find I3 only, I will be able to find my V out. So let's target this. Okay, so let's substitute everything in terms of I3. So equation 4, we can say that your I2 is equal to I3 minus 4 milliamp. So this is equation 4 dash. So this is your I2 is equal to this. Now we can come up to equation number 3, equation 3, and we can say that the K will cancel with the K. So your basically your I1 is equal to 7 over 5 I2, which is equal to 7 over 5. I2 is basically I3 minus 4 milliamp. And this is equation number 3 prime. So now I know I1 in terms of I3, I2 in terms of I3. So 3 and 4, we'll take these two and substitute them in the fifth equation. Okay, so substitute 3 prime and 4 prime. So these two equations in 5. In equation number 5. Okay, so we will have here first minus I3, so minus I1. I1 is equal to this, so it becomes minus 7 over 5 I3 minus 4 milliamp plus 2I2, so it is 2 times I3 minus 4 milliamp plus I3 equal to 0. Let me multiply everything times 5 to get rid of this 5. So it becomes minus 7 I3 minus 4 milliamp plus 10 I3 minus 4 milliamp plus 5 I3 equal to 0. Now let me collect here. We have 10 plus 5, 15 minus 7 I3, which is basically will be 8 I3. And this is minus 7 plus 28 minus 40 plus 5. So this will be equal to 12. Okay, now from this, your I3 equal to 12 divided by 8, which is equal to 1.5 milliamps. Now your V out is equal to 10K times 1.5 milli. The milli will cancel with the kilo, and this will give you 15 volt. This is how we handle a mesh question that has a current source that is basically between two loops, and also revision how to deal with the dependent sources.